In the unfinished Lewis structure for C2H4ON with an overall negative charge as shown below, what is the hybridization of the orbitals around nitrogen, the second carbon, and oxygen respectively? So before I start solving this problem, I'm going to complete the Lewis structure. Because in our case, we can't see where the lone pairs are because this is unfinished. So to start with nitrogen, we see that it has 4 electrons due to this double bond. To complete its octet, I'm going to add 2 lone pairs here. And to make sure that this negative charge on nitrogen makes sense, we can verify that using our formal charge equation. So we know that our formal charge is going to be the number of valence electrons, which in the case of nitrogen is 5, minus the number of non-bonded electrons, which is 4 due to our 2 lone pairs, minus the number of bonded electrons divided by 2, which gives us -1. So it does make sense that this negative charge is on nitrogen. And then moving on to carbon, it has 4 bonds, so an octet is satisfied. All 3 hydrogen atoms have 2 electrons. Our second carbon also has an octet, but our oxygen does not have an octet. It only has 4 electrons in this case, so we need to add 2 lone pairs to complete the octet. And now our Lewis structure is finished, and we can move on to finding the hybridization of the orbitals. So to find the hybridization, I'm going to count the number of regions of electron density. And this does have an exception for conjugated molecules, but in our case, we don't have to worry about that. And we can use this method, which is really nice. So I'm going to make a chart that relates the number of regions of electron density to the hybridization and also the shape. So if we have 2 regions of electron density, we're going to have sp hybridization due to one s and one p orbital, and the shape is linear. For 3 regions, we have sp2 hybridization due to one s and 2 p orbitals, and our shape is trigonal. And we also, for 4 regions, have sp3 hybridization, and our shape is tetrahedral. And these are the most common. These are usually what you're going to see in these problems. So I'll also go over what counts as a density region. So the first thing is bonds. But I do want to note that for double and triple bonds, this only counts as 1 region. And the second thing is lone pairs count as electron density regions. So now I'm just going to count the number of regions around the atoms in question. So for nitrogen, we have 3 regions because we have 2 lone pairs, which each count as 1 region, and we have a double bond that counts as 1 region. So therefore, that is sp2 hybridized. And then moving on to the second carbon atom, we have 4 density regions because we have 4 bonds. So this is sp3 hybridized. And lastly, we have oxygen, which has 4 regions because we have our 2 double bonds and our 2 bonds on each side of our oxygen. So this is sp3 hybridized.